Alright everybody, so this video is going to discuss the most common problems with the Precision Radiation Instruments 111B, and actually for that most part, even the 111s too, that would prevent immediate operation when you buy one of these. So other than the obvious, which we've discussed many times over, is this problem. The water damaged or moisture damaged crystals that are attached to the photomultiplier tubes. All right, so there's definitely many ways you can approach this issue. You can obviously replace it with the Ukrainian 40 by 40s, 30 by 30s, or even a 25 by 25 millimeter sodium iodide crystal, and it'll work perfectly fine. These things tune up really well. They're built to calibrate to many different sources at many different ranges, and it's very accurate. There's no problem adjusting and tuning these things up to different size crystals, unless you go too big. But the thing is, you can only fit a crystal so big in here, and I've never been able to overrange this thing with a crystal that just barely fits within here. So I think whatever you get, you're going to be pretty fine. Whatever fits in here, you should be able to calibrate. Also, as the new discussions are popping up about resurfacing these crystals, you can resurface them, but the thallium contamination issue is very serious. It's a major risk, and I really don't recommend doing it unless you've got glove boxes, PPEs, and all sorts of different things to keep any contamination from happening. So, but other than the crystals and all this stuff, what we're going to talk about is the electronics inside that need to be fixed before you try firing this up. Now, as many people have found, you buy these things, you put a power supply in here, put the batteries and stuff, and it may work to a certain degree, but eventually it will fail. There are a host of capacitors inside that are a problem. There are some jumpers on the range switch that short out. There's some issues with this, the power cord. There's some issues with the battery box. And then there's a very formidable issue with the meter. So before I open this up and we discuss this, there's one last thing I want to point out. The RCA 6199 photomultiplier tubes that are commonly used in all the 111s and the 111Bs and the 115s, I believe the 117s, these things are really bulletproof. This one here I'm holding is the only one that I've found so far out of all these 111s and stuff that I've been rebuilding that I found is bad. This thing is, you can kind of hear it, it's loose inside, and I don't know, it was probably bad not long after this thing was installed, so I don't know, but this is the only bad one ever, even out of the detectrons. So it's not bad odds if you look at the numbers that I've been dealing with. So if you have any issues, it's most likely going to be the electronics inside and not this tube. I would not default into thinking these tubes are bad until it's like you've eliminated every other possibility. Okay, so let's open this thing up. These things are fairly easy to open up. It's just kind of a twist lock design. You just slide and twist this thing open and pull it out. I've already taken the photomultiplier assembly out, so when I take this apart, you're not going to see it plugged in. So what we're going to do is we're just going to get into the circuitry, and I'm going to show you certain things that need to be replaced. All right, so let's move on to that. Okay, so the very first thing is going to be the battery box. And inside the battery box, you have this little holder for the 22.5 volt batteries, which go in here between these two contacts, and the 4D batteries. This one is lightly corroded, and you're going to look at this and think it's heavily corroded, but I've seen some that this is like crystal clean compared to how bad these things really get. This is actually salvageable. This is not too bad. But all the corrosion here normally has to get cleaned off. The insulators here on the positive side of the D batteries, if you look closely, it has like a little fiber or paper insulator between the ground and the positive contact. So sometimes the corrosion will cover this and cause a short. So that obviously causes a problem. The other thing, all right, is this. You're going to see this piece of tape holding an insulator, a little paper insulator, between the two D batteries on one side of this. Okay, this insulator has to be intact. If the ground from this D battery connects to the grounding side of this D battery, it will completely short your entire system out and your unit will not work. You have two filament supplies in here, and that's what these D batteries are for. You've got one for the pulse amplification circuit and another one for the high voltage circuit. The grounding system between those two circuits cannot be connected, and that's what this little piece of paper is for. So make sure this is intact. Make sure it's good. Take it out, check it, make sure there's no holes, because sometimes these things wear through, and just by putting a little bit of pressure between the two, which is common by putting your batteries in here, it'll still short out and you're going to have a problem. And the problem is reflected A, in non-operation, and B, on the meter here in the back, it goes full range. And you're going to be doing all sorts of things to try to figure out why the meter's pegged when it's actually this problem. Now there's another issue within the circuitry that causes a full range meter deflection, and I'll get to that in a minute. Another video which I'm going to discuss a little later on is upgrading this power supply, because this thing here, with modern day alkaline batteries, you can power this whole thing off of 2D batteries, two 22.5s, and only one 67.5 volt battery. You don't need to hook up two. Now getting onto the 67.5 volt batteries, all right, now this one, the leads that connect the 67.5 volt battery break. All right, these things were just not soldered on well. It's just very early methodology on putting these things together, and it just wasn't thought through very well. But they break off. These solder joints are not good, and just double check these things and make sure they're not on the way to breaking, because they very well could break. Okay, so let me open this thing up and I'm going to show you a couple other issues. Okay, so now I got the end removed, and as I told you, the photomultiplier assemblies have been previously taken out of this, but it just plugs in here as so, and these things are normally all covered up with black tape, and the crystal is taped on the end. So, but once you get to this point, you may wonder how you're going to remove this circuit board to get in and replace some of the bad capacitors and other things. And it's actually very simple. You only need to do just a couple of things. You need to take off this selector knob, and you need to remove the set screw for the selector switch. Once you remove that, this whole assembly will come out. You do not need to remove any of the potentiometers on the top. You don't need to remove the recorder plugs, and you do not need to remove the time constant switch. The only thing you need to do is just remove this knob and the set nut that holds the switch in place just below it, which I'm going to show you here in a second. Okay, so with a standard Allen wrench, the knob comes right off, and then all you got to do is remove that nut right there, and this whole assembly will just gently rock out, and you'll be able to work on it. So when we remove this, the one thing you got to be careful of, it does give you some extra lead to work with, so you don't have to worry too much about it. But the zero adjust and the calibration potentiometers have probably about 2 or 3 inches of extra wire space, so you can pull this thing out, as well as the meter. Just don't yank it out real hard. If you're gentle with it, it'll give you just enough space to work with and solder and do whatever you got to do and put it back in. So I'll take this off and we'll pull this thing out. Okay, so you can see how loose it is. and we'll be able to rock this right on out. Okay, so here it is out, and it gives you plenty of room to work with. And there's usually just a few points here that you got to deal with. Before we get into the things that need to be replaced, the last thing that you're going to want to do to get in here with the soldering iron is you need to remove the PMT holder bracket. And this is very simple. There's always this little small rubber washer here in place that kind of holds this in place. So you have to gently get this off. It's not too difficult on this end. And on this side, on the bottom, you just have to remove this screw right there. And this whole assembly just pulls right off. So why don't we go ahead and remove the screw in the bottom, and I'll show you how this comes off. Okay, so once you do that, this opens right up, and now you have unfettered access to just about all the connection points on this side and on the back side to fix anything that needs to be fixed. One thing to keep aware of, though, again, kind of like the battery solder points that I was showing you, the solder points holding the PMT socket onto the circuit board are not the best as well. So in addition to retouching up those soldering points, make sure you keep note of exactly where these wires are connected. There's 3 wires. In this case, you got a blue, a red, and a green one connected to the circuit board. Just take a picture or note down exactly where they're connected, because in the midst of doing all the manipulation and soldering and moving this thing around, it's common for these things to break loose. So you just want to be able to know exactly where to solder this thing back if it happens. Okay, so let's move into capacitor replacement. The ceramic capacitors, these black discs here, they do not need replacing. I've never run across one that's really out of tolerance to an extent, or bad, shorted out. These things they just last forever. They never ever go out. Even in the cases of the old-fashioned radios, the 1950s and 60s radios, anything that uses these old ceramic capacitors, they just generally don't need replacing. By all means, you're recommended to go get a capacitor checker and double check them, but you'll find that you'll almost never need to replace those things. But the paper capacitors absolutely need to be replaced. And regardless of what the capacitor checker says, you still need to replace them, because many times these things will show in spec with the capacitor testers, but when they're under load, they leak. And that is the last thing you want. And when they leak, these things do all sorts of crazy things. Sometimes you'll have full meter deflection. Sometimes you'll have very, very, very poor voltage control. Sometimes you will have very low count rates. It causes all sorts of crazy stuff with the bias in the sub-miniature tubes here. So every one of these things, and there's only 3 that need to be replaced. All right, so what you have are 2 0.1 200 volt paper capacitors. All right, and you have one small one here. The smaller ones are the 0.1s. There's one right here. They're either going to be orange or black. All right, these are the orange varieties. So you have one here on the range selector switch, and you also have one here on the back. Okay, these are the 0.1s. They have to be replaced, and I can't stress that enough. You leave them in there, and even if they're working for a little bit, you will have problems. So replace this one and replace that one with a 0.01. These things are really cheap. So here's the 0.1s. And you can get these things off of eBay or Mouser or what have you for like pennies. They're not all that expensive. And next to the 0.1 here is a larger one, and just for historical purposes, they call these things phone book capacitors because obviously they're paper and they're wound up, and these larger ones, in this case it's a 0.25 at 200 volts, kind of looks like a phone book. So anyway, this one also needs to get replaced, and this is the new version of that. Now, the tolerance of these things are pretty wide. So if you can't find a 0.25, which is actually pretty common not to be able to find it, a 0.27, which is very common and very cheap, and this is a 0.27, you can use a 0.27. Just don't go up to like a 0.30 or something like that, you'll be fine. So 0.25 is good if you could find it, and 0.27 will work. Easy to solder these things in place. All right, so let's move on to some issues with the selector switch. Okay, so the selector switch, it's all point-to-point wiring, and the range resistors here, you do need to get a high megohm type resistor checker, because even though these things are pretty well made, every once in a while I've found these things to have failed. Sometimes they're completely shorted out, other times they're open, and other times their resistance have just gone off the charts into different directions. So check these. There's like about 6 or 7 of them, depending on what model you have. And but for the most part, 9 times out of 10, when you're going through these 111s and 111Bs, these things are good. But when you start really doing a lot of repairs on these, you will occasionally find one that's messed up. Okay, so the other problem, now this one is very common. Let's say you go through the whole thing, you replace capacitors, you fire it up, and you get full meter deflection. It's pegged, all right? That generally indicates you have a direct short. The number one place on all 111Bs where you get a direct short is this jumper right here. Okay, this is a jumper from one range selector resistor over to the next. It is not supposed to be grounded, so they have this little plastic sleeve that goes over this jumper from the top side. This is this little yellow thing. And it is sometimes when they assemble these things, they put it right up against the grounded selector switch post. And over the last 63 years, the pressure on the backside against the selector post has split the plastic, and the internal conductor is shorted directly against straight to ground here. And that short causes a full meter deflection, almost like if you took a battery right up against the terminals of the meter, and it does not move. No matter what you do with the calibration, no matter what you do with the zero control, it will not make any difference, because this short totally causes a disruption in the circuit, which leads to that effect. The other thing is, this isn't the only jumper like this, and it's going to be kind of hard to show you with this camera, but you may actually have to take the set screws of the selector switch off the bottom of the circuit board so you can lift up this switch, because there's between 2 and possibly 3 more of these things in different locations. Sometimes they don't have them at all. And I think when they assembled these things back in the 50s, some of the assembly technicians decided to go this route with one, and then they didn't do it with others. Others, they'll put 2 or 3 of these things across the selector switch posts, causing multiple shorts. But I believe this particular model that I'm displaying right now only has one. So the first thing you'd want to do is just cut this whole thing out, get yourself a piece of wire, and is it well insulated, just make a nice loose loop and just connect it right here. There's plenty of room. I don't know why they didn't do that and they decided to make it so tight up against this, but destined to failure, and this is one of the main problems that the 111Bs have. Okay, so moving on, now we have to deal with crusty switches and potentiometers. And again, no matter how well these things may run when you get it, it's still a 63-year-old instrument. There's still going to be corrosion. There's still going to be some crust and problems within your switches and your potentiometers. So this is probably about the #1 brand for deoxit, and I would say that I'd recommend this one. I've always used it. I've been using this honestly since when it came out in the 80s or before. Well, obviously it's been out longer than the 80s, but When I first started doing electronic repair, this is the #1 brand that we used way back in the day. So it's still around and I like it. All the contacts in here, you want to spray liberally, and then once you get a whole bunch of saturation within all the contacts, obviously you would want to have your knob on here first, switch it back and forth a whole bunch of times to break free any crud, then maybe zap it one more time with some spray and you're good there. The calibration control potentiometer and the zero, okay, this is a little bit more difficult to get to. So to get to the side that you can spray the internal portion of these pots, you may have to take the meter off, which is still no problem. Just 3 screws and this thing comes right out. Or, you know, just kind of like we took this switch out, you can take this set screw out and pop it out and put it back in. But if you decide to do that, one thing to keep in mind, this circuit board will not fit back in here unless you have all the wire connection points of these meters, or I'm sorry, of the potentiometers pointed all the way back towards the meter. You cannot have the wire connection points facing this way because the spacing is really tight in here, and the back of this board will crush up against the connection points. So these connection points have to be rotated towards the back. So to avoid dealing with all that, really I recommend just taking the meter off and zapping these things with the deoxit from the meter side. Okay, so other than that, the last little bit I can tell you that you would want to do is, again, they really, in many cases, didn't leave much slack in these wires. So just, you know, this has actually been one of the better ones, but many other of these 11 or 111s and 111Bs, these jumpers are really tight up against other jumpers. Sometimes these jumpers are underneath resistors and capacitors, and just the pressure of the components on top of one another have caused these wires to split and potentially short out on other components. So just make sure all of that is good, and because sometimes you just have this little hidden problem. So I think I found probably about 5 or 6 times where these things have split because they've been pushed up against too hard. So that's another thing just to keep a lookout for on both sides of the board. Let's see, the spiral cord. Okay, so these things get crusty. Usually, if the cord is still kind of pliable, and this one's getting a little bit on the petrified end, but if there's no cracks, then your conductors within the cord are usually pretty good. Where you're going to have problems are in the exposed areas, where the individual wires come out to their connection points on the battery area and within the unit. So double check these things, because the insulation on these wires were not meant to withstand the trials and tribulations of time, and they petrify and they crust, and sometimes the insulation breaks off and they short out. So double check that. If you got any issues, then a worst case scenario is you got to replace the cord. There's a couple of posts I've made before where, you know, where I've replaced the cord, and it kind of shows how this is done. And if you don't have to replace the cord, then you can just splice in another wire to fix that one problem. But I'm sure most people here on this group are pretty familiar with doing that kind of stuff, so that's not an issue. Okay, now here is the last problem, and this is the big problem. All right, you think all this other stuff could potentially be big. This here is the big problem. If this meter is shot, and I'm talking about the spring being loose or stretched out, or the meter itself being bent, I'm not a watchmaker, I'm not a watch repairer, but you really do need to be a very, very good watchmaker type person, you know, with some of the ability to deal with all little small jewels and different adjustments and stuff on the inside to get that fixed. I don't know anything about spring repair, and I can tell you right now, the cost of taking one of these original meters and sending it in for a complete rebuild would probably buy you, 3 or 4 111Bs. And out of 3 or 4 111Bs that you can get probably 2, maybe 3 good meters out of it to replace whatever you're working on here. There's also a good replacement meter. The Victorine CDV 717s, I believe, are the only meter that has one that would work as a direct replacement for the 111B. And that's going to be a whole nother video post in and of itself if I should ever decide to do it. But it requires a little bit of dissection. You have to take the meter face out of this and put it obviously in the 717 meter. It's not a direct bolt-in replacement. You'd have to make some modifications to get it going. There's some other methods about printing out new meter faces and adhering it to the existing meter face of the 717, so it's just a drop-in replacement. That also works very well, but again, that's for a whole different video, and I think this video is probably drawn on long enough. So if that ever comes up and the group wants to get into that, I got some resources that have been provided to me by someone who's a lot more knowledgeable on the subject that I'd be willing to share. So, all right, I think that is about it. I'm sure I missed out a lot of different small things. Well, I'll point out this also. The sub-miniature tubes, I've only had one circumstance where there was a bad sub-miniature tube, and I believe it was from a previous owner who was taking the front end of the meter apart, probably haphazard or carelessly, and caught onto this sub-miniature tube here, breaking the end off. And obviously that rendered it useless. But, sub-miniatures, if you do some research on these things, they represent the absolute pinnacle, the height of vacuum tube technology. That's why these things were primarily used for military applications back in the day. They're very resistant to shock and all sorts of harsh conditions. So these things that are around today, probably 99 times out of 100, if not 999 times out of 1,000, these things are always going to be operational. So that's just been my experience with them, even back in the 80s. All right. Well, I hope this has been some help to some people. And obviously, any questions, feel free to ask. If I messed up on something or misspoke on something, feel free to point that out so we can get that clarified. And by all means, change out those capacitors. Top priority. All right, guys. Talk to you later.